Hey guys, Ollie from FlightComp here, and I have a sexy FX F3K model that I built for a customer of mine. And I filmed most of the build process, so I thought it'd be a good opportunity to share with you guys how it went. It was the first time I built one of these. And pretty simple, really, pretty straightforward F3K build, no real issues. Kind of fiddly getting all the 4 servos in the nose and having space for the battery and the receiver and all that, but once I figured it out, it went good. I had to cut the slots in here for the Aileron linkage exits. That wasn't a big deal at all. All the models I have coming from now on will have these slots already cut. Tails all standard. F3K fare, nothing out of the ordinary there. And yeah, so let's dive right in and I'll show you how the build went. Getting ready to install all the control horns in the FX. As you can see, I've put some masking tape around the slots, and I left a little bit of a perimeter that I tried to scuff up a little bit so that we could get a little bit of a fillet from the horn onto the surface. And when the epoxy is sort of like halfway cured, you can pull the tape up and it'll leave you with a really clean installation on the horns. So I've done that on both the ailerons, and I've also done it on the elevator and rudder, as you can see here. Here's the rudder. And on the horns, I've really scuffed up the areas that are going to be inserted into the control surfaces. I've scuffed them up with some coarse sandpaper and also scratched them up a lot with the tip of an X-Acto knife. So I've done that to the aileron horns and the rudder and elevator horns. And I'm just going to use 15-minute epoxy to glue these in. Okay, continuing with the FX build, I got all the control horns installed, the epoxy's cured, and right now I'm moving on to doing the aileron linkages. So I've put some bends, 90-degree bends, in one end of the linkages here. So you can see. And I've put them through the horns. I previously cut the slots in the fuselage. You guys won't have to worry about this because all the fuselages will come with the slots already cut. But to do that, I actually got the original file for the fuselage, and I made some 3D printed templates and just used these to cut the slots so I could get nice, neat slots. So those are cut. So the push rod is in and routed through to the servo area. The next thing I'm going to have to do is work on the servos. So I'm going to have to get the servos in position and cut down these push rods a little bit and mark where they need to bend to get to the servos. Now the servos, I'm using the KST X08s, and they've all been, or I have put them all in shrink tubing. You can see there's shrink tubing wrapped around this. The kit is supplied with a small piece of shrink tubing you can use. And once everything's ready, I'll just sand down, scuff up one side of the servo, or the shrink tubing I should say, and then I'll glue these into the fuselage. Now the arms I'm using for the servos, for the X08s, are these guys here, and there's 2 that look like this in the servo box, and one is like a conventional servo arm, and the other one, which is this one, mounts more flush to the servo body. So if I mount this on the servo, you can see what it looks like. So that's the arm you want to use. And I've prepared the actual aileron arms here. I've cut off all the excess and left 2 holes, and I've opened up those holes to 1 millimeter, and I've just cleaned them up a little bit with a Dremel tool to make them nice and round and everything. Okay, so I'm going to move on with trying to get the servos positioned and making the bends at the servo arms. And the servo arms do have to get put in not straight up and down, so they're going to be angled forward slightly. So I'll figure out what that angle is and let you know. Okay, I am moving ahead with the aileron linkage. So again, I have the push rods hooked up on the horns, and I have the two servos temporarily installed with just some double-sided tape on the bottom just to hold them in position for now. And what the GCM calls for is deflecting the ailerons down 5 millimeters. So as you can see, they're down on both sides 5 millimeters. And the control horns that I showed you earlier are deflected forward about 1 tooth, or between 10 and 15 degrees. So they're slanted forward slightly like this. Instead of being perpendicular straight up and down, they're like this. And then what I've done is I have marked both the push rods where they would attach to the servos. So I've marked these with a Sharpie on both sides. So what I'm going to do is figure out the length that these plastic sleeves need to be and trim them down. And then after that, I will make the bends here for the servos. But I'm going to do all of that with the push rods and sleeves removed from the model. So I cut the tubes down. I'm leaving about, I don't know, maybe 15 to 20 millimeters gap between the servo arm and the end of the tubes. Now that the push rods are cut down, I'm going to go ahead and remove the push rods from the fuselage. I'm going to keep the sleeves on the push rods, and I'm going to make my bends here for the servos. Okay, well I actually finished the, well not quite finished, but basically almost done the aileron servo installation. So I did scuff up the bottom of the servos, and I have used CA to glue them into the tray. And I made the bends and the push rods and hooked all of that up. Maybe I can zoom in here and get you a better picture of what that looks like. See that right there? Turn the plane a little bit. So there you go. I left as much of the push rod coming up as possible because I think I'm going to end up gluing these down to the sides of the fuselage. I haven't done that yet. And one thing I did was on the forward servo here, so this guy right here, I changed the arm. So previously I told you that I used the arm that sits really flush to the body of the servo. Well, that limited the up aileron travel, because basically when this arm rotates forward, the L bend would hit the case of the servo. So I went back to a more conventional arm where it sits further away from the servo. So let me just show you this. Move the camera. So you can see on the forward servo there's more of a gap right here, and on the rear servo the arm is flush to the case, so there's not any gap here, but there's more of a gap here, and that allows the L bend to clear the case of the servo. So that's a change I made, and I'm getting very good travel. Plenty of down and plenty of up. Now these are the recommended settings from GCM. Okay, moving along, I've finalized the aileron push rod installation. I've glued in the sheaths and trimmed them down a little bit As you can see right here, I shortened up these L bends to about 8 millimeters. So this length right here is 8 millimeters. And so there's glue here. I tried to go in from the inside too and put a few drops of CA in here. So I got a few drops on the back side and the front side here. And then I have also put a little bit of epoxy right here to hold the push rods on the side of the fuse. And the L bends here at the servos, they're about 4 millimeters long. So next thing to do is to install the vertical stabilizer or the rudder. And what I've done is scuffed up the inside of the fuselage a little bit and cleaned it with some alcohol to prep that for the epoxy. And I've also scuffed up the mating surface on the rudder itself with some coarse grit sandpaper and clean that off with some rubbing alcohol. So I'm going to go ahead and mount the rudder, and I'm going to do the upside down workbench method. Okay, so I've actually already installed the vertical. The epoxy is drying. I put a little bit of 30-minute epoxy on the inside of the boom, then slid the vertical on. It kind of jigs in, but there's still a little bit of play. You can see the airplane is upside down on my bench, and the peg is not installed, and I didn't install it just because I knew I was going to do this, so I want the wing to lie flat, or the wingtips to be flat when it's upside down. And I simply just used a square and held it up to the hinge line. The hinge line on the hinge side of the rudder, so that would be this side, is actually flat, so it doesn't taper. So if you line the square up to this side of the rudder, you're going to get a square vertical, and that's what I've done. Time to put the throw peg in. Not much to do here. Here's the peg. It already came sort of scuffed up from the factory, so I don't have to worry about that. I'll clean it up with some rubbing alcohol just to get the carbon dust off of it. And then I've simply used some masking tape and taped off the notch, top and bottom. This will just keep the installation clean, and we won't get epoxy going everywhere. I'm going to use a very high quality slow curing epoxy mixed with a little bit of Cabosil, not much, and all I got to do is slip it in there. Now the peg does have an angle on it, so you got to make sure that when you put it in with the dihedral, the peg is the blade part is vertical. So that would be like this. So make sure you get it in the right way. So again, pretend this is the wing. If the wing has dihedral like that, you'd want the throwing part to be somewhat vertical. So just look out for that. Well, I must admit that I jumped ahead quite a bit with the servo installation. I got all the servos installed now. The cables are hooked up to the tails. So basically all the controls are hooked up. So we have two other X08N V5s in front of this bulkhead. So the elevator here and the rudder is right here. And then I have glued in some pieces of the plastic tubing and routed the pull strings through those tubes just to help keep the strings in place and more to the sides of the fuselage so we can get the ballast in without worrying about snagging anything. The arm length on my servos is the same arm length as my ailerons, so you can, rewind a little bit and see what that was. You could make these a little bit shorter, but the strings would bend down quite a bit or drag because they would have to clear the bulkhead. And I talked to GCM about this, and they basically said this is the way to do it, so I went with the manufacturer. So here we go. Again, I've got the standard crimps It's all standard F3K stuff, so there's nothing new here. The elevator servo does kind of go up and into this sleeve. If I had to do this again, I would cut this crimp a little bit shorter, but the way it is now, it works perfectly, so it's okay. We got these tubes bracing the aileron linkage here. They're epoxied in. And then the tail is quite standard. So we got the horn, elevator horn back here. You can see that right there. And then we have rudder horn. And again, I cut the slot basically under the pylon for the exit for the rudder string, and I used a little bit of the plastic tubing to acts like a guide, so the string's not rubbing against directly on any carbon. That wraps up the servo installation. I am going to shorten some wires because the receiver is going to go in this area here. Probably sit right here, and we just have, these wires are just too long, so I'm going to shorten some of these up. And then, like I said earlier, the peg is glued in. Epoxy's not dry yet, but once I slid the peg in with the epoxy, I used a paper towel with some rubbing alcohol and wiped everything clean, and then I peeled that masking tape off, and that left us with a really clean install. So we'll let this cure overnight. So I'm going to go on with shortening up these wires, and then I'm going to get into getting the receiver in there and the battery and probably the CG. Alright, well, I have basically finished up the model, so I'll give you a look. It looks like a mess, but I have shortened up these wires considerably. And I have a little extension. This is a servo plug to a JST. And I have a single cell. This is a single cell 500 milliamp lipo. This weighs 14 grams. And I've just soldered on a JST connector here. Now the dimensions on this is about 48 millimeters by 20 millimeters. And I had to try a few different batteries to get one that fit. You really can't use anything longer than about 50 millimeters. And nothing wider than 20. So I would say 15 to 18 millimeters wide if your battery's longer than 50 millimeters. I think maybe one of those round Hobby King 600 milliamp cells might work in here. You only have about I don't know, 55 or 60 millimeters of length to play with. But anyway, I found this to fit perfect. It's a again 500 milliamp, 20 by about 48, and it fits in right there in the nose. And now my customer is using a Airtronics or Sanwa radio, and this is a 6-channel receiver. It's pretty large, so we're putting a pretty big receiver in here. I had to take the case off. There was no way it would fit with the case. If you're using newer stuff or FR Sky, or you're using some kind of S-Bus or X-Bus receiver, you're gonna have a much easier time fitting your gear in here. With my JR gear, I would use JR X-Bus with a little tiny infinity receiver. That's just a little tiny cube that would drop right in here, no problem. But anyway, this guy's gonna go in the nose right here, and then I'll hook up all the wires, and then we'll see what it looks like on the CG machine. All right, so we're all done. Let's take a look at the CG. If it'll get on the screen here. It's about 61.3, and the weight is 232 grams, so the weight is pretty good. It's going to be slightly heavier because of the two-piece wing, so probably about 10 grams heavier than a model with a one-piece wing. That's to be expected. So I was hoping for the CG to be in the 64 to 66 millimeter range. We're about 3 millimeters in front of that. And I'm going to go ahead and blame that on the big old receiver I have stuffed in there. I don't really want to try to go to a smaller battery because, you know, the flight time is going to be diminished greatly. Alright guys, I think that's going to wrap it up for this FX build. I don't think there's anything more I can really tell you on it, so I appreciate you guys watching this. I hope you guys enjoyed it, and I will see you guys again in the next one. Bye.